Okay, guys, welcome to this Min-StarkNet build. Today we'll be Darlington will be showing us how to build an ERC20 token, right? I'm trying to get the list. Okay. Okay, yeah, an ERC20 token, an ENS app, an ERC721 token, and an NFT marketplace. So let's just see how he was able to like build this mini project like in 2 hours time, right? Are you see them on?
Yeah, I am.
Okay. Are you still having network issues, no?
I think it just got better now. I just hope it keeps up at this pace. So we starting now or are we waiting a while for more persons to join in?
It's recording, so definitely we can just watch
All
it
right,
later.
okay now. Okay. All right, then we can start now. Let me just set up something. All right, try sharing my screen. Can you probably make me host or something? I can't see my screen.
Oh, sorry about that. Okay, I just made you co-host. I think you can do that right
Oh,
now.
all right, let me try to. Right. Can you guys see my screen?
Yeah.
Okay. So, basically, what we're going to be doing today is, we're going to be going through, we're going to be learning Cairo basically by building, small projects. So, the Min-StarkNet project was, a project that was influenced by Miguel and Piedrafita's Lil Web3. So the whole idea is create different a minimal implementation of different protocols and standards in a certain language you get, and people interested in learning can learn by trying to build those, probably build alongside something like that. So I decided to create a Cairo version of it, and so I think the README is quite detailed. So anyone interested in following up, there are instructions on how you can actually do that. So I think the first thing you need to note is for the project I use Protostar. So you don't necessarily need to use Protostar if you do not want to. But if you would like to follow maximally, I think it will be easier doing that with Protostar. So in short, we wouldn't be going through how to set up Protostar, but if you go through the official docs, I think the instructions in the docs is quite very clear. So there's also the fact that it doesn't support Windows OS currently, so you probably need to run a Linux OS using WSL. And so after you install the Protostar, after you install Protostar, right, you need to go ahead to clone the repo by running the command below the terminal. So but I need to edit this though, because currently the project has two branches, right? We have the master branch which has the full implementation. The whole idea is for you to serve as a guide. There's a develop branch which gives a simple boilerplate which you could actually use to build on your own. So once you probably have gone through the master branch and you're interested in starting out on your own, it's advisable you clone the develop branch to the develop branch. So okay, so we are going to be using the develop branch. Let's just basically, if you go through the master branch, you can see you probably see the full codes you get. You see the whole implementation. But the develop branch was created to be a little different. When you go through the develop branch, you don't see the full codes, but you will see their interfaces. So, for example, if you go through the AMM contracts, you wouldn't see the code there, but you can see the interface. So, they're the interfaces too. And give you, okay.
Yeah, I think your voice is not completely clear. Can you hear me very well? Can you hear me very well?
Yeah, I can hear you very well.
Yeah, but yours is not like so clear like that. I don't know if anybody is like encountering something like as me. But then you can just like continue. Just if you can do little adjustment and continue.
Well, does it sound like a network issue, or do you think it's a Bluetooth issue or something?
Probably Bluetooth or something. Non-network.
I think Bluetooth now. Yeah.
Okay, let me try using my laptop as the microphone. All right, is this better?
Yes, this is better. Yeah, this is perfect.
Okay. All right, let's use this then. Okay, so the interface, like I said earlier, the develop branch has interfaces rather than codes. So the whole idea is the interface should like guide you on your process of development. So looking at it gives you the functions that are really necessary to implement, right? So the whole idea of the project is not for you to start cramming codes, but the whole idea is, okay, these are the functions we need, right? This is what the application does. Can you build out this logic on your own using Cairo? So that's the whole idea, not for you to like start cramming codes and doing stuff to get. So I think we're going to be trying to apply a model that works, something that will probably help you along the way if you are looking to probably build on your own. So this is develop branch, right? So as you can see here, we have a list of the projects that is contained in the repo, right? So we started with building very simple applications in case you are learning. So we start from very simple stuff like building a simple ENS service. So ENS stands for Ethereum Name Service, and we build a very simple implementation of it. So as you can see here, there are also links to like the contract on StackScan. So in case you are interested in checking out the contracts or playing around with it, you can actually use this already deployed contracts. And there's the ERC20 contract, which this is the ERC20 contract, which basically uses Open Zeppelin library, import Open Zeppelin's library, and build your own custom ERC20 contract from it, right? Then there's also the part where you get to build an NFT token, that's an ERC721 token. So after that, things begin to get a little harder. We go into building an NFT marketplace. So I saw always the GitHub repo. All right, okay, let me paste that here. Oh, sure. Yes, sure. What's wrong with this now? Sorry, I got a new keyboard and that's been quite frustrating. Experiences online, okay. Yeah, that's the link to the repo. Okay, so then we go forward to start building more complex contracts. We go into building an NFT marketplace. So the idea of this contract is to probably to teach you, or like for you to learn more about how contracts, how to use contract interfaces. If you want to interact with other contracts, how can you do that? For example, to be an NFT marketplace, you probably definitely need to interact with an NFT contract. So you learn that by building the NFT marketplace contract. Then next up, we go over to building a simple EMM in Cairo. Now, this is a much harder project where you get to build stuffs by separating logics. So most times to keep your codes use decorator, then the function is probably is definitely an internal function. You could see a lot of its application in Open Zeppelin's libraries. So we'll go back to building an EMM, a simple EMM on Cairo. Then we also built an IC on Cairo too. So ICO stands for to use this. So ICO is this a minimal implementation of pre-sale of a pre-sale in Cairo. So ICO stands for initial coin offering, right? So we're going to be building this on StarkNet. So you could read more about it here, but when we get there, we'll probably dive deeper into that. And we're going to build a staking contract. So a staking contract, staking is a popular process, right? That we've probably encountered if you've been in the ecosystem for a while on Ethereum, the process by which you can lock up a certain amount of your tokens, crypto holdings, and you earn rewards or interest. So we're going to be building something similar. The whole idea is get to know how to use the block, the timestamp, and a whole lot of other cool features. Then I think these two are like the very hardest ones, but they are very key things you need to know as a Cairo developer, a StarkNet developer, right? You need to know how to build custom messaging bridges. So the beauty of StarkNet is it enables you communicate between StarkNet and the base layer, that's Ethereum. So the messaging bridge we're going to be building helps the user transfer ERC20 tokens between StarkNet and Ethereum. So we are going to mostly be writing the StarkNet part of the contract. So I'm going to explain the Solidity contract to you. So if you're interested in checking it out, you could still check it out. But then we get to understand how communications work between L2 to L1. Then lastly, we're going to be building an upgradable contract. So with the topic of Genesis at hand, it's a necessity for you to understand how upgradable smart contracts work, right? Because when we're transitioning from Cairo 0.9 to 0.10, as at then it was easier, and Darknet created a means for it to do this easily using I think the command then was Cairo migrate, right? So it was available with every framework, but it wouldn't be that easy with Cairo 1.0, because Cairo 1.0 is not just very little syntactic changes. Like there's it's almost a total rewrite to make Cairo look more like Rust and be far more developer friendly. So if you don't know how to create upgradable contracts, then it will be very difficult migrating your existing contracts to Cairo version 1.0. So basically the idea of an upgradable contract is for it, allowing you to change the underlying code or logic of your smart contract without necessarily altering the entry points. That's the contract address of your dApp. So you can do that by separating your contracts into a proxy and an implementation. So the proxy is what serves at the entry point, and it also holds the contract storage while you can change or swap the implementation. The implementation contract is the contract that contains the code or logic of your decentralized application. So there's a very good article that StarkNet's developer advocates, the Liberato wrote here, so you can check it out. And also Open Zeppelin created a good template for us to follow. So when we get there, we would understand how that works too. So, but for today, we are going to be focusing on these first 4 contracts, right? So building a simple ENS, deploying to StarkNet, building an ERC20 token, deploying to StarkNet, building an NFT token, deploying to StarkNet, and if there's time, we'll still build an NFT marketplace and deploy to StarkNet. But even if we can't do that, we'll definitely go through the codes and still try to deploy too. So to get started, basically, like I said, there are two branches. I would want us to just clone the develop branch alone for this, right? So I'm just going to open my terminal. Okay, let's just right, and we're going to be cloning just a single branch, right? Let's git clone that. I think there's a command. If I got that, let's go this one now. Single branch, right? The value. Then I think this should be the loop does not exist. Sorry, let me get that command again. It's git clone single branch. Oh, interesting. All right, git clone single branch. I think going to the loop branch, and keep making this mistake. Sorry guys, but this command never sits in my head. I've probably tried it thousands of times. Let me go check again. Clone branch. You guys just give me a minute. Let me find the right command. Git clone single branch, key branch. All right. No. Single branch. Starts with the single dash. Interested. Okay, double branch master. Okay, develop, and then it's yeah. Right, my network is not the best currently, so this might take a little more time than necessary. So I'm just going to chill for a while. So, but while we do that, so if you are totally new to Cairo, we're doing our best to carry you along, but this would be a little more difficult, but there are a lot of good resources, and if you are just starting out, I wrote some blogs which could help you out. So, oh right, thank you. I didn't see this sometime. All right, so if you're just starting out, there are a lot of helpful resources. We compiled a few of them, I think, on the group chat and on the Twitter handle too. So if you head over to I think StarkNet Africa's Twitter handle, shall retweet the post here. Check out the tweet. Right, my network is really set out to mess me up today. Sure. Wait, can you guys still hear me? Paul, can you hear me?
Yeah, we can hear you.
Yeah.
All right. I honestly do not know why my Twitter is not turning up, but let's just move on. So, but if you are new to like Cairo, this would definitely be a little more difficult to follow up with, but I'll be trying my best to carry everybody along. So let's just see if this has finished. Okay, this has finished coding. So basically, but I would just probably drop links to that later on the group chat, the compiled resources we made earlier, and we're going to probably make a more updated one soon. But you could also check out my Medium, right? Why when I started learning Cairo, I wrote a lot of helpful articles of stuff I learned along the way. So this would definitely be helpful if you are looking to learn Cairo. So basically for this um for this class, right, we are going to be making use of three resources. We are going to be making use of Protostar, we're going to be making use of Agent X, and we're going to be making use of StackScan. So Protostar, okay, we could start from, this is still not opening. Okay, it has opened. All right, but let's first of all, we're going to be using Protostar, right? So let's check docs. So yeah. So Protostar is a tool chain, think of a framework for writing Cairo. So think of Truffle, Hard Hats, and Foundry for Solidity. So Protostar is, in my opinion, I would say, in my opinion, it's one of the best, if not the best framework you have out there for writing Cairo. The beauty about Protostar is it enables you write and test your contracts in both Cairo, unlike other frameworks where you probably have to learn Python in order to write tests. That's one among plenty other host of advantages Protostar presents. So I would say I have special preference for Protostar. So we are also going to be using Agent X. Okay, we're going to be using Agent X. So if you don't have Agent X installed, you could just head over to I think on Chrome Web Store, right? Head over to Chrome Web Store and you should find Agent X extension over there. So you can just click add to Chrome. Mine is showing remove from Chrome because I already have Agent X installed. So well, for you, it will probably be add from Chrome. So the last tool we are going to be using is StackScan. StackScan is a block explorer for StarkNet. So think of Etherscan for StarkNet. So we'll be using it a lot to like interact with our deployed contracts. So probably look towards getting those three tools. Now we're going to move into the Min-StarkNet folder. Right. I'm going to move into the Min-StarkNet folder. I'm going to open this in our code editor. So for code editor, I'm using VS Code, but you could use whatever code editor. Just like I said, we're going to be if you go back to the repo, right, the instruction says that you should where is that, right? Okay, I can't find the particular instruction, but there was a place I stated, okay, yeah. So for maximum efficiency, I would advise you follow it in the order specified as you should start with the mean ENS project before moving to the mean ERC20, because that's how but you could still choose to build whatever project of your choice. If you are probably above the rest, you could start with the ones you want to start with. Or for these classes, we'll be starting out with the ENS project, right? So we're just going to go into the ENS interface contract, right? So inside here, you can see we have our contract interface for the ENS contract, but the interface alone might not be very helpful for you to probably write, as in completely write your contract, especially if you do not understand what the contract is set to do, right? So this is what I would advise you to do. So I'm going to run this. Okay, I'm going to run this side by side with that's the master repo, right? The one that contains the main contract. And we are going to like go through the contracts. Not this. This is the develop branch. So we're going to go through the contracts and we are going to try to like understand what the contract does, list out the stuffs we need to create, and that should help us a lot. So as you can see here, our ENS contracts, first of all, implements a storage variable names. So this storage variable, the name storage variable, it maps as a name to each address. So what we'll just do here is we're going to probably use comments to right. So I'm going to use comments, and I'm just going to say we have a storage variable, right? Okay, let's just do the storage variables. Storage. I just switch to my default keyword because that will be long. Variables. Okay, so for storage variables, we have a single storage variable that's names. So we're going to write that down, right? A storage variable name. A storage variable names. All right. Then the names map, the storage variable names map addresses to names, right? Then we have an event that's going to be emitted. So we have an event that's going to be emitted called an event stored name. So the stored name event is meant to be emitted each time like a name is stored using the store name function. So we are going to have a constructor. We're going to have a constructor. We're going to have a constructor, and inside the constructor, we are going to be storing the first name we are going to be storing in our contract is the name of whosoever deployed the contract. So the person has to pass in his name, and we are going to be getting the deployer's name, and we are going to be storing that name, right? But then there's a catch to this, right? The essence of doing this was just to probably show you how you could store a name as in sorry, the essence of constructors, right, is to like preset some specific variables in your contract. So the idea was just to show you how you could do that in Cairo, because when you call, okay, with the recent updates, right, that was done to the StarkNet 0.10.3 updates, right? Currently, if we call the get call address, we'll probably get the address of whosoever deployed the contract, since we'll be paying for fees using our AgentX wallet. But in previous versions where we had to use the deploy syscall, doing this will probably return a zero address or a random address, because deployment then was free. But currently it works. But the whole idea, the whole point I'm trying to prove is probably in a real ENS application, this is probably not a very necessary logic. So, but we're just going to do that. We're going to implement a constructor. We're going to implement a constructor where we'll store the name of the deployer. We'll store the name of the deployer. Right. So then we are going to be implementing firstly an external function, right? So we're going to be implementing an external function called store name. So the idea of the external function, right, is to get a name. Whoever wants to store a name, right, to supply the name he wants to associate with his address, right? So we're going to get the person, the address of whosoever is initiating the transaction, and we are going to map, like, store the name side by side the address, right? So we are going to we're going to come here and we're just going to say external function, right? Okay, yeah, let's just say external. I have problems right here. People is not so good. External function store name, right? Store name, and so we say stores name of caller. That's the person calling the function. Stores name of caller. And we lastly have a view function get name, which you pass in which accepts an address, right, and returns the associated name of the address. We're just going to write view function get name. So the whole idea of this function, right, is to return associated name of address argument, or associated name of address. So having done this, right, we now, I would say we now have everything we need to actually build our contracts, because we have our function accepting, and we should have had a proper understanding of what the function logic is actually supposed to do. So the next thing we're going to do is we're going to try out building out the logic ourselves.
Some of the things Darlington did while we wait for him to join back in. Sorry for the network issue. So let me just quickly share my screen. I'll go into the repo. So can you all see my screen?
Yeah.
All right, cool. So has he already explained any of this, or should I just start from the first and down? Hello, can you hear me?
Yeah, I can hear you right here.
Yeah, so has he already explained any of the repos?
No, not yet. He was trying to explain
Yes, I mean, it was on this ENS repo, but then probably can just like glance through it before starting up.
Okay, so I think ENS and EMMs are kind of more specific. So let me just do something that I would quickly understand, because I've not really gone through this repo before. So let's go through ERC721. Is that okay? That's the NFT contract. That's fine, right? Can you hear me?
yes, it's fine.
All right, cool. So as we already know, ERC721 is the NFT standard, non-fungible token standard. So let me just quickly go through the code and explain the Cairo code, and we'll go ahead from there. So basically, this is if I'm just trying to assume that you don't really know much about Cairo, which might not be the case, but I want everybody to be on the same page. So this long StarkNet basically says that this contract is a contract, right? And not just because you can use Cairo to build a normal contract, a normal program, which is not a smart contract. Because one difference between a smart contract and a normal Cairo program is that there is an absence of storage. So just like you're using Python to write code, like you're just using Python functions, you don't really have anything called storage, except you now want to bring in something like your database and stuff like that. So if you want to tell the compiler that this is a contract, you need to add this here. So now it sees this as a contract, and you're able to use things like this, which is a variable, right? So let me just quickly go through this import. So this is the hash built-in, which is basically, this is a built-in. So a built-in is basically a set of pre-written code that you would import so that you don't have to do those things yourself. So for instance, there are some hashings that happen when you try to call from storage, but then because of things like this hash built-in, you can now perform those things without, like, see where they are used here. They are used in these places where you have system call, this. So all these things are built-ins, and this is one of them. So basically, this is the type. So this is the pointer, right? So this is the pointer here. So just basically built-ins are just we use them so that we don't have to write this thing from scratch, because they are, is either we won't implement them the way it's meant to be implemented, or won't do it in a very efficient way. That's why we are giving these things beforehand. So this is a struct. This is the UNT56 struct, which is basically the reason why it's implemented this way in Cairo is because they are trying to emulate the UNT256, which is already existing in Solidity, right? UNT256 is a native data type in Solidity, which means unsigned integers, right? So here they are trying to do that, but because it's not native, we now use a struct. And in this struct, you have two values, right? You have the low and the high. And because in Solidity, the UNT256 is able to take in 2 raised to power 256 values, but then in Cairo is not the case, because you have other things like rather the failed data type is not up to UNT256, right? It's more like 2 raised to power 252, which is not complete. So we want to be able to represent that in Cairo. So we now use a struct whereby we have two values, the high and low values. So right now you don't have the low value, which takes in a failed, which is 2 raised to power 252, and then we have the low and the high. Right, so because we can't express it exactly the same way, we now convert it to a struct so that we can be able to do something similar in Cairo. So this is quite self-explanatory. This is more like message or sender if you have a Solidity background. So this is more like message or sender, get caller address. Then all these contracts are contracts from OpenZeppelin, right? Because if you already know Solidity, you would know that OpenZeppelin is more like an industry standard when it comes to building some things that some things that are popular, like say ERC7, ERC2, ERC20, ERC721, ERC1155, and some other utility functions. You would notice that OpenZeppelin already has an implementation. So actually they have things like this in Cairo, and it's already being used widely. So we have this is the implementation of ERC721. This is the implementation of ERC165. So this ERC165 has to do with interfaces, right? So just know that it has to do with interface. This doesn't have anything to do with NFTs directly, but basically this has something to do with interfaces. And this is the popular own label that comes with OpenZeppelin, which allows us to enforce ownership. So basically, the popular is this modifier in Solidity only owner, which stops you from calling a particular contract if you're not the owner. So this is the Cairo alternative, right? So basically, let's quickly go ahead. So this is the token counter, which is basically a way to keep track of your tokens, right? So if you want to be able to, if you have an NFT contract, most times we give out NFT based on values, numerical values, and we increment them by 1. That's linearly, right? So the first token ID is 1, second is 2, and so on. So this is basically a value that helps us keep track of that. So as at any time, if the value is say 2, then that person, then when the value is 2, it means that the last person that we gave an NFT or minted an NFT has a token ID of 2. So we increment it as we move on. So yeah, so this is the constructor. So if you notice, and I want to apologize again, if you know all these things, pardon me, I'm trying to assume, I want to carry everybody along. So I just want to say these things again. So in Solidity, you have this constructor as a keyword, right? The constructor function is like, you can just use it the way it is because it's inbuilt Solidity. But here, even if we named this thing something else like initializer or starters, no matter what you name it, so far you have this decorator. So basically, decorator is more like a modifier. So you can see a decorator as a modifier. So if you have a Python background, a decorator, you know about decorator, or if you have a Solidity background, the decorator is more like a modifier, right? So anyway, you see something like this is a modifier. So what modifiers do generally is that they modify existing code, right? So basically, this particular code converts this to a constructor. And what is a constructor? Based on popular knowledge, a constructor is more like any function that you call once when you're initializing an object. And in this case, our object is the Cairo contract, this ERC71 contract. So as at the time when we are deploying this contract, we call this once and it can never be called again. So that is what this does, right? So this is the initializer. Then this enforces, rather this sets the owner, right? So basically this ownable, like I said, as is being used here, this sets the owner, right? This sets the owner to the person that deployed it, right? So basically I'm saying I will initialize it passing my name and my symbol. Then if I'm the one that deployed this, then I automatically become the owner. And you see in other functions where I enforce this ownership. Understand? So like I said before, the ERC165 has to do with interfaces. Most times if you want to implement in an interface, they would ask you for this, right? But I don't think there's any way that this is being enforced in Cairo, because we don't inherit here. I don't think this is enforced, but just for consistency, this is being used here. Or if there are other reasons, I don't know, but this is what I know about it right now. So moving on, this is the name, which, like I said, we already declared the name here. Rather, we already said the name here. So this function gets the name. It takes in some implicit argument, like I said. I said we use built-ins, and all these are built-ins, and they are passed in as implicit arguments, right? So these are implicit arguments. Why? Okay, this doesn't take in. Okay, so this is not an argument. Sorry, this is not an argument. So this is just a return value, right? So the name function doesn't take in any value, and it just returns the name. Now I want to point out something. Now, if you see this thing, you see this modifier here, view, right? What view does is that it says that this contract, rather this function, doesn't modify the state of the contract. It can call from the storage of the contract, but it can't modify. So what do I mean? This contract can call, like it's calling this name. So this name now is in storage, it's calling it, but it can't modify. If you're coming from a Solidity background, you would know pure. Cairo doesn't have pure. To the best of my knowledge, it doesn't have pure. But then if this was pure, it won't even be able to call from the state. You understand? It won't be able to call from the state. But then since this is view, it can call from the state, but it can't modify. So that's just something to point out. So we come here, we're calling the symbol, want to get the symbol of this particular NFT, the balance of, so basically if we pass in an owner, we want to be able to get how many NFTs the owner has. So mostly what we are doing here is just basically using what this contract has already given us. So moving on, the owner of, so basically the name, I think the name is self-explanatory. If you pass in a token ID, we can be able to get the owner of that NFT, because only one person is entitled to a particular NFT. So that's kind of straightforward, right? So that's what this function does. Then get approved. So basically just more like I want to be able to sell my NFT on OpenSea, but then I need to be able to give OpenSea the access to sell my NFT for me. So basically this is a function that checks the contract that this particular NFT is being approved. So basically, if I put in a token ID here, and let's say I've already approved OpenSea to spend my tokens, the address should be returned, because basically this returns the address of the contract or the protocol that I've given access to my NFT. So that's what this does. Then this is more like another version of this. So basically what this does, that it checks the contract that it checks the protocol that you gave access to spend a particular token of yours. But then this function checks that the protocol you gave access to spend all. Because for instance, you might have 20 tokens in a particular NFT contract, but then this one gives us the ability to see, because most times we just set only one or two, you understand? But then in other cases, you can actually make it possible for you to set that a particular protocol will be able to spend all your tokens, which I don't know, it's not really advised, but then in most cases, like say, if you go to OpenSea and if you go to OpenSea and, or rather if you create a contract through OpenSea, because OpenSea gives you the ability to create your own contract. So if you create a contract contract, they create the contract for you. Basically, they have this already, right? Because they'll be the only one approved, right? So they'll be able to spend all your NFTs in that contract. So this is the function that does the approval for one NFT. Then this is the function that does the approval for all your NFTs, right? So this is the popular transfer from function. You probably know this is just a way to transfer NFTs in and out, rather out of your contract. So this is more like a safe version of this. So popularly, right, the way safe works is that in normal transfer functions don't confirm if the receiver can actually receive NFTs, because there are sometimes there's a particular address you send your NFTs to and you know that it's gone, right? But what the safe function does is that it makes sure that you actually, the contract the address you're sending it to has the ability to hold NFT, right? If it's a contract. So there are ways to check if an address is a contract, right? So the way it's being used is that it checks if the receiver is a contract. Then if it's a contract, it checks that that particular contract implements a particular function, right? If that contract implements a particular function, that means the contract is aware and is ready to receive NFTs, which it can then go ahead to send out, right? So basically, once you have the interface, once you implement a particular function, I'm sure that, okay, yes, you can receive this NFT and you know what to use it for. But then if you don't have that, I assume that you are not aware of receiving NFTs, and there's a 90% chance that if I send the NFT to you, it's gone. So that's the difference between safe and normal transfer from. Then this is just a function to mint. Now, look at where this thing comes in, assert only owner. So basically, this is Cairo equivalent of a modifier that works like only owner, right? So basically, this checks that the caller is the owner that was set here, the owner that was set here, right? So basically, this is what this does. This is what this does. Then basically, it reads the token ID of the previous, increases it by 1, then it's mints a new NFT for you with the new token ID, then it increments it by 1, right? So so far that's that for the NFT contract. Before I go ahead, let me quickly check, is Darlington back? And also, please, if you have any questions, please just go ahead and ask. Okay, I've not heard anything for a while. Can you guys hear me? Okay, I think Darlington is back.
Yes.
Hello, can you hear me?
Yeah, we can
Yeah,
hear
yeah.
you. You have a question.
Nice, cool. Okay, you have a question, go ahead, please.
Yeah. The get approve function. Get approve function. It said it's going to return the address of the contract you approved, right?
Yes, the contract that you've given access to be able to spend your NFT, a particular NFT.
Is there an institution whereby you can approve more than one contract to spend the NFT?
Okay, so here's how, if you were using, like, say an ERC20 token, right? It is fungible and it is transferable, right? So you can easily approve different contracts to spend a particular NFT, right? Sorry, a particular ERC20 token, because you might have 50 and one person will spend 20, another person will spend 30 for you. But then since NFTs are just one and they're not exchangeable, how it works is that you can only approve a particular contract to spend your NFT. But then since it's per NFT, you can have 4 NFTs and you approve one to OpenSea, you approve another one to Foundation, you approve another one to Rarible, you approve another one to Rainbow or something. So basically, yes, you can approve per token. You understand? You can approve per token per. So a particular token, let's say token ID of 5, you approve it to OpenSea. 6, you approve it to another protocol. But then you can approve one NFT to multiple contracts, but you can approve multiple NFTs to multiple contracts. It might not be different, but then you can only approve one NFT to a particular spender. Does that make sense?
Yeah, sorry, to get it right, you need token ID, like let's assume I'm approving token ID 1 to OpenSea. I cannot approve
Okay.
I cannot approve another protocol that same token ID.
To best of my knowledge, no. Or rather, it's based on these things are not enforced. You can write code no matter how it seems right to you, but these things are based on what I've seen and what I've built. Most times, you want only a particular spender to be able to spend your NFT.
Thank you very much.
All right. Okay, does any other person have any other question? Okay, I think Darlington is off, but then all right, let's just go ahead. Okay, let me try my hands on something that's no, because I've not gone through this myself. I don't want to. Okay, let's just try the ENS and see. Let's try the ENS and see. Oh, okay. It looks straightforward. All right, so can you guys hear me? Let me be sure. All right, cool. So basically, this is the Min-ENS, which is basically an implementation or a minimal implementation of what the Ethereum name service looks like, right? So basically, the ENS is a way to attach names to your address, right? So basically, instead of having this 20 bytes random hex value, instead of that, you just have your name.it, right? So you can have logo.it instead of having a long address. In fact, I think most of us know how ENS works, right? But yeah, that's just it, by the way. So then we have these two imports that we already saw back there: get caller address and hash built-in. Now we have two storage variables, which is names and stored name. So now this is how. So if you're coming from a Solidity background, like I've been saying, you would know something called a mapping, right? So in mapping, you map a value to another value, right? So just like say dictionaries or objects, or depending on how you want to see it, but basically just mapping a value to another value and having a key. And so this is more like no, okay, no. This, I think this is the mapping, if I'm not mistaken. Yeah, this is just a value. This is just a variable. And this is okay, this is an event. Oh, sorry. So this is just a variable that stores an address, right? Then, oh, I was actually right. Sorry, guys. So yeah, this is a mapping. So it maps an address to a name, right? Then this is an event. And I think it is being emitted when you store a name. So let's just go through this quickly. So this is the constructor. This is the constructor. Like I said, it gets the caller address, it gets the name, it gets the name. So as at the time when we are initializing this contract, we pass in a name. So in this contract, we attach a name to the caller address. So basically, as at the time when you're deploying this contract, you should add a name, right? You should add a name. So just for clarity's sake, this is Cairo, and we have everything is like we have only one primitive data type, which is the felt data type, right? And how this is represented is you use for instance, if you want to pass a name, you would have to convert that text to felt. And when you convert the text to felt, then you pass it in as a felt. And a felt is a number, right? A felt is a number with modulo, and when A is a prime number, a very big prime number. I think we just released the thread on that. So just in case you want to really read about felt, I think it's on the group chat now. It's on the Telegram channel right now. So yeah, so basically the felt, if you, let's say you have, and also note that the string, currently existing string in Cairo, must have 31 characters. So how do I mean? So if you want anything you want to write, it should be within 31 characters. If it's more than 31 characters, then Cairo doesn't see it as a string. All right. Or yeah, it doesn't see it as a string. So basically anything you're writing should be within 31 characters. So that's that. So basically you change your name to a felt, you pass it. No, and now when I'm saying this, I mean if you're you're calling this contract, if you're deploying it. So you have to go and convert any name you want to use to a felt. And then if you go to a tool like StarkScan, which is more like Etherscan equivalent in Cairo, you would see that you actually see the name you used, right? Because so far you converted it from string, they'll be able to convert it back to string. So then you get the caller address, we get the name, then when we add the caller, we store it. So this is how this mapping is being stored, right? So this is the caller and this is the name. So now this is a way to store name. So basically we get the caller address, we write, then we emit, right? So this is a way to emit event, right? So this event here, we emit the address and the name. And yeah, this is quite straightforward. Then if you want to get name, we pass in the name, and from the name, we can get from the name. So this address, oh God, I was mistaking the return value for the arguments. Yeah. So this is the address, which is the argument, the explicit argument. Then we pass it into this mapping to get the name, right? So that's that for this contract. So let's go back. I think that this contract was quite straightforward, but if you have any questions, just go ahead and ask and I'll do my best to answer. So before I go ahead, let me just quickly send. So let me go ahead and go through. Okay, let's go through the ICO contract. So just in case if you didn't know, the ICO is an initial coin offering. So basically, so it's called so it's more like an equivalent of how people were raising funds in the past. I don't really see a lot of ICOs now. I see more like pre-sale, and I think it's similar. Pre-sales are similar to ICO, but basically they try to raise money by taking an existing token for a new token that's coming up. So that's just the basic idea, right? So okay, let me first ask Darlington, are you good or should I?
Yeah, I'm
go
good
ahead?
now. I'm good now.
All right.
Can you hear
all
me?
right, cool.
Yeah,
Hello,
Yeah, I
can you
can
hear
hear
me?
you, bro. I can hear you.
All right. I want to apologize. I greatly apologize. I don't know what happened in my network, but it totally went mistake, and I had to just run inside school to see if I could get access to a better network. Well, I'm just going to continue. Okay, I think Godfrey already did a good work of explaining most of the contracts. So we're just going to go straight into writing and trying to deploy them. We don't have a lot of time. So, okay, really good. That's a question. I noticed storage variable parameters does not have a field data type in the ENS contract. Is that how it works for storage? The storage variable parameter. Let me check that. Okay. First of all, let me just share my screen. All right. Can you guys see my screen now?
Yeah, I can see.
Okay. That's actually an error. It would actually compile, but it's not like that. That's not the right way to do stuff. It's actually supposed to have specify the data type. So, but let's just try this ourselves, right? So, we're going to first of all import the Sorry, I'm no longer on my monitor, so I can't do double screens with my GitHub. So let's just do this ourselves. From starkway.cairo.common. Cairo built-ins, right? Cairo built-ins. We want to import the hash built-in, right? Which we're using for our predecessor hash. Okay. Sorry, give me a minute. Keyboard shortcut. Modifier keys. Can this thing stop blocking my? Oh my God. Anyone knows how I can hide this stuff? It's okay. Let me just move it up. Okay. No. Let's just close this. So let me switch something. Option, command, control. Okay. So why is this not working? Might have an issue here. Let's just write this. Min-StarkNet.Cairo.common. Then I don't think we'll be needing any other thing. So let's just define our storage variables. So that's names, which is a mapping of address, which is supposed to be of data type field to like the name. Then we're going to have our events, right, which is going to be called stored name. So this should the event stored name, right, should emit the address that was stored with the name, right, the address and name which was stored. Then we are going to move out our constructor. I'm just going to use this replace this with constructor, and then the constructor is going to take in I think it's going to take in a name argument, right? A name argument of type field. I'm trying to, since my keyboard is having input issues because I was trying to, let's just move on. All right, so we are going to get the call address, but to do that, we're going to import the get call address built in from starkware.starknet.common.syscalls. We're going to import the get call address. So we're going to then see let caller be equal to get call address, and we're going to call the storage variable. We're going to write to the storage variable. We're going to write the caller in association with the name, and then we're going to return. So having done that, we are going to try to implement our external function, which is called store name, right? Store name. So store name from our interface, it takes in just a name argument, right? So we're going to pass in the name argument, and then as well, same stuff, we're going to get the caller. We're going to get the caller, and we are going to different names. We're going to write the names variable, right? The caller and the name, and same stuff. We're going to return. Okay. Before we return, we're going to emit our event, right? So the name of our event is stored name, right? So we're going to call to emit an event. You're going to say stored name dot emit, right? And then you're going to pass the caller and the name, right? Following what we have here, an address and a name. So the caller and the name. And lastly, we are going to implement our view function. Let's just use the external, since that brings up the template, the function template. So we are going to call this get name. The get name function is going to it takes in an address argument, right? And we are going to say better way to do this is we're just going to go ahead and say let's return names.read, and we are reading the name for that particular address. We're going to just return it. So we are going to I don't know if you have any questions, you probably ask on the chat and I'll check the chat. So we are going to compile our contract. Firstly, we're going to do that, we're going to head into protostar.toml, and I already have a contract listed out already. There's ENS contracts, but our name does not correspond, so we're just going to write this to ENS. We don't have an ERC20 contract yet, so we are just going to comment these ones out, unless it's going to throw an error when we try to build our contract. So we're just going to comment these guys out. Comment this guy out, comment this guy out, and the prosy guys too. All right, so having done that, we're just going to head straight into our terminal, right? And to build a contract with protostar, you just need to run the command protostar build. So if everything works well, our contract should build. Okay, there's an error, return names, or it says cannot. Oh shit. We wanted to return an argument, right, with the getName function. So over here, we're supposed to specify that we are returning a name field, right? So let's do this again. All right, so we've gotten our contract built. So each time you build a contract with protostar or okay, let me expand this. So each time you build a contract with protostar or any other framework, right, you're going to the build folder, you'd find two files. The ENS ABI contains the ABI. So in case you want to interact with your contract from from a front end, right, this is what you're going to be using. Then this is what we're going to be deploying, right? So we're going to deploy our contract, we are going to first of all declare the contract, right? But to declare our contracts, we like I said earlier, with the recent update to StarkNet 0.10.3, right, the previous deploy command, which enabled you to deploy contracts for free, was and declare contracts for free, right, it was deprecated. So in order to do this, you would have to set a wallet from which you would have to be paying gas fees for your deployment. So what's going to happen is first of all, you need to specify the wallet you want to use, right? You're just going to head into your agent's wallet, right? All right. So once you head into your agent's wallet, you are going to let's say I want to use account 1 for deployment, right? You're going to come here and you're going to export your private key. So for privacy reasons, I'm going to stop sharing my screen. But before I do that, here's the command you use to set your private key in your terminal, right? You can use the command export protostar accounts private key. Okay. And you are just going to paste your protostar address, your private key. So if this is my private key, right, I'm just going to copy this, right, and paste this here, but this is not my private key. So whatever is your private key is what you're going to paste here to set your private key. And another alternative, right, is to create an env file here, probably pasting your protostar your agent's private key in it, your wallet private key in it. And then when you go back to the terminal, you'd while declaring or deploying your contract, you'd have to specify the path to which protostar can access your private key. But using this command is the easiest way to do it. So what's going to happen is I'm just going to stop sharing my screen for a while, and I'll set my private key. So once you cover the private key to a byte 32, well, that was necessary initially, but with the recent protostar update, I think that's 0.0 words. Are you sure this is even up to date? I don't think this is even up to date. 0.9.0. Sorry about that. So please, minutes.
Hey man, are you still there?
Yeah, I'm still here. Sorry about that. Okay, so I was actually explaining that you don't need to convert your private key if let me check the recent protostar update. Let me be sure that repo is up to date. So to do that, I think let's check releases, right, for protostar. The recent release was 0.9.1, so my stuff is not even up to date yet. So this is I'm going to update this to 0.9.1. But if you have a little protostar installed, right, you don't necessarily need to do that conversion. So but if you're still running 0.9.0, you probably have to do it. So I'm just going to stop sharing for a minute, and I'm going to set my private key, and then we'll continue from there. Right. All right. Key is equal to export personal account private key is equal to this, right? And having done that, I'm going to just clear this. Yeah. All right. I'm just going to start sharing once again. And I know we are moving a little bit faster. So if you have questions, just ask in the chat and I'll attend to them. So now we're going to head over to declaring our contract rights. What's this showing up? So we're just going to say, can't even see my screen. Okay? So I'm going to say protostar to declare with protostar. You just use the protostar declare command, right? And if you ever probably forget the input to your commands, right, you can come to the CLI reference in the docs, click on the command you are looking to use, right, and you can see the required inputs. So we are just going to be passing in protostar declare, right? We're going to first of all be specifying the particular file we want to declare. That's ENS dot, let me confirm that, ENS.json. Okay, ENS.json. So we're going to be building the ENS.json, declaring the ENS.json file, and we're going to be passing in our account address. That's the account address for like the particular. So this was the account I used. This is the private key I set to my terminal. So I'm just going to copy the account address, and I'm going to pass it in, and I'll pass in the account address. I'll need to pass in what else? I think the max fee. Okay, I'm going to be using testnet, so no need for this stuff. So I'm just going to pass in the network I'm going to be using for this is just testnet. Testnet is now better, so there's no need to use testnet too. So and I'm going to be passing in my max fee, right, which is I'm just going to set to auto. So is the ENS small letters? Well, apparently, as you can see in the build folder, it's ENS.json. Because I actually used a small letter ENS. It doesn't it's not irrespective of what you, as in the name of your file, right? But the name you use here exactly, the this is what is actually Putz actually uses to name your compiled files. So I don't know if that clears your question. The max fee serves as what? Okay, the max fee is when you are actually like deploying using the terminal, right? You would want to, you don't want you in a case where gas fees are probably high, gas fees spike up, you want to specify like a particular, should I say a particular fee which you don't want to go beyond, right? So it's just like saying, okay, for the declaring of this contract, for the deploying of this contract, right, I don't want to go beyond 0.002 way, right? You just need to specify the max fee you want to pay for that contract. When you set it to auto, you're actually saying pay whatever fee you can pay, like as in whatever fee is needed for the contract, just pay it. So that's just how it works. So we've currently declared our contract, right? So this is the class hash of declared contract. So you could head over to StarkScan to check if your contract was successfully declared. So just copy this, and if you head over to StarkScan here, sorry, just search for that class hash, and you can see our class hash was successfully declared. So we are just going to deploy our contracts now. So we're just going to say protostar deploy, and we're going to be deploying this class hash. Okay, this is the class hash of the contract we want to deploy, right? We're going to be passing in first of all our inputs. So our construction inputs it requires a name. All right, it requires okay. Yeah, constructor inputs, this is ENS.Cairo, right? It requires a name. So like okay, we've said in previous classes, right? Cairo just has a single data type field. So strings are not acceptable in Cairo. It's not a valid data type. So if you are going to be supplying a constructor argument, it needs to be in data type fields. I'm very sorry for the background noise. So, but to do that, there's already a utils.py conversion file here that you can actually use to convert from string to fields. If you don't want to use that, also there's also an online should I say an online tool you could actually use. I'll just paste this in the chat because this is what we're going to be using.
not going to be running scripts today. So you could actually use this tool for converting from strings to fields. So I'm just going to use Darlington here. I'm just going to use Darlington here. That's not Darlington, this is Darlington. So I'm just going to copy this, the field representation of Darlington, and I'm going to head to our terminal, right? And I'm going to pass in that as our input. Then I'm going to be specifying the network we are going to deploy into, that's testnet, and also the max fee, which is auto. So once we do that, we should have okay, command deploy expect argument. Oh, right, we are supposed to specify the account address of the private key we are using, right? So we're going to just copy this account address and we're going to paste that in. So having done that, we should have, so basically what happens here is, when you deploy with the current update like 0.10.3, right? I said the previous deploy command was deprecated. So currently, the way we deploy to StarkNet, right, is you need to invoke what we call a universal deployer contract. It's just a standard for deployment currently on StarkNet. And I wrote an article on that. So in case you are not familiar with universal deployer contracts, you could just check out this blog. You could check out this article. It shows more light on deploying to StarkNet, declaring contracts, universal deployer contracts, and stuff. So there's a chart. What is the purpose of the class hash generated after deploying? Okay, the class hash is like the class hash contains, think of the class hash as your contract without a storage. So it just contains the contract code, but does not, as in contains, not a contract. Like it's not a contract because you can't interact with it. It has no storage, but it specifies the codes in your contract. So your class hash can be very useful. It's basically a way you tend to tell, should I say, it's a way you provide, should I say, to the universal deployer contract, right? The codes of that class hash, for example, now represents the whole code for that particular smart contract. So that's just basically it. So when you declare a contract to generate a class hash, when you deploy a contract, you generate like a contract instance. That's just different between both of them. Right. So I don't know if that answers your question. All right, thank you. Yeah, sure. Okay, so we are beyond schedule already, and it's mostly my fault. So we're just going to copy this contract address and we're going to be checking if it's already deployed. So we're just going to head over to StackScan and we're going to search for that contract address. And yeah, it's already deployed. So as you can see, we have our contract here, and you could read and write to it. So we're going to just, if you click on get name rights for this particular address, it should return Darlington if everything goes right. So I'm going to just check the stuff for this, right? Oh, seriously, it doesn't return it. I think it wasn't particularly set. Okay, let's try this first. Let's try to connect our wallets, right? Let's try to store a name. Let's use yeah, once again, okay, we need to use the field representation of Darlington. So okay, let's just get that from the tool we used earlier. Is the field representation of Darlington. So we are just going to head to StackScan and we're going to paste that in here, and then we're going to try to write, okay, and we're going to approve this transaction. Right. Should take a while. But testnet is faster now. So let's say in a minute or so, we should have that so when that transaction goes through, we are going to try to query for the name of the address and check if it returns the name, the associated name we added. So while we wait for that, right, we are just going to be heading over to the second contract because we are mostly out of time already. So having worked on the ENS contracts, right, we're going to work on the ERC20 contract next. So I'm just going to create a new file and I'm going to call this ERC20.Cairo, right? And so if you, let me check if this is completed. Not yet. Well, if you cloned the repository, right, you should already have your Open Zeppelin library installed. You can find it in Cairo contracts. And if you go into source, you should see Open Zeppelin Zeppelin, you have access to the ERC20 library here. So this is the ERC20 library. You could just open this to the site. So Open Zeppelin has, just like we have them saving our ass in Ethereum layer 1, right? They still have a lot of well-written audited contracts. You could probably import and use to build your own custom tokens, and they make the process so easy. So we're going to be creating our own ERC20 contract today by using their library. So let's check if this is completed, right? So we are just going to query the name associated with this my address, right? And I'm just going to paste this in, and I'm going to query it. And as you can see, we get back Darlington. So I think that wraps up for the ENS, the Ethereum name service. So if you just have any question, just ask in the chat, and I'll answer it. So, but let's head over to our ERC20 contract, right? So for ERC20 contract, as always, we would start by specifying our language directive, right? So like I said earlier, this is how we specify that, okay, this is a StarkNet contract. It's a StarkNet contract, for example, and we're going to just move over to importing our respective functions or whatever we're going to be importing from the library. Okay, we're going to need from the Cairo built-ins, right? We're going to need the hash built-in, which we use for our Pedersen Pedersen hashing, right? The Pedersen what is called implicit arguments, right? Then we are going to import from starkway.cairo.common.un256, right? We are going to be needing the UN256 struct. So basically in Cairo, like I said earlier, there's just a single data type, that's the field data type, right? So in order to create a UN256 variable, you have to use a struct comprising of two fields, right? So supplying two fields, fields like two fields. Let me show you how the struct looks like. So if you head over to the Cairo Lang library, right? All right, so we're just going to head over to yeah, this is it, right? So this is the struct. So it comprises of two fields of 128 bits. We have the low value and the high value. So this is basically how you create a UN256 out of a field, right? So there has been a lot of arguments as to whether having a UN256 is very necessary on StarkNet. I think there was during the earlier days, that was around July or so, there was a strong argument around it, but at the end we settled for this because we believe that compatibility or alignment of StarkNet with like the base layer, that's Ethereum, makes more sense, right? So if you are probably going to be building cross-chain application, would it be called, or cross-layer applications, right? Across StarkNet and between StarkNet and Ethereum, it makes sense. It makes things simpler if we have should I say similar data types, right? So that's why UN256, having a UN256 data type for your ERC20 token was standardized by Open Zeppelin. So you're going to need that. We'll probably, I think that's about it. Is there any other thing on it? Well, if we need to import any other thing, we'll do that along the way. So firstly, since we are using Open Zeppelin's library, we probably would definitely not have any need for specifying storage variables or events, since that has already been abstracted away by Open Zeppelin. So we're just going to start with creating our constructor, right? And I'm just going to use external in order to get all this. I still want to right, this is still not working, and I don't know why. Probably check it out later. All right, so so let me just close this out, so I'll have more space. Just close this out. Yeah, so so this is a constructor, right? So in case you haven't written a StarkNet contract, right, you'll be wondering what this is. So this is called a decorator. This is called the decorator in Cairo. And there are needs for decorators because if you notice, unlike Solidity, where you can probably within functions specify external or public or whatever it is, right? Type of function that is, right? On in Cairo, every function looks very familiar. You just have the funky words, the name of the function, your implicit arguments in curly bracelets, and then your your normal arguments in brackets, right? And so in order to differentiate between functions, the compiler needs to you need to specify a decorator in order for your compiler to be able to differentiate between different functions, right? So as you can see, if you went to our ENS contract, you can see for an event, right, we have to specify the at event decorator. And for a storage variable, we have to specify the storage variable decorator. So that's exactly what decorator does. So we're just going to, for a constructor, the name has to be constructor, right? That's very compulsory. So our ERC20 contract is going to take some certain arguments, right? So we all know that for an ERC20 contract, it must have a name, right? It must have a name, it must have a symbol, it must have the decimal specified, right? It must have the decimals, sorry. You must have the decimal specified, right? We would also need the total supply, which will be a unit 256 value. And then we are going to need the recipients, which is also a failed data type. So does this mean if you don't know the upper limit of your number range, you should use unit 256 that is struct number range? I don't think I understand that question.
Please, can you hear me?
Yeah, I can hear you. I can hear you.
Like, if you don't know how big your number will be, you get.
Yeah.
Since felt is not as big as you in 256. Hello.
Yeah, your line is actually breaking. You said something. What were you saying?
Now, since felt is not as big as you in 256.
Okay.
So there's a chance the number you want to use might be bigger than felt.
Okay.
So is that the best time to use in 256?
No, not really, not really. I don't think there's most numbers you would want to use would fit into like the felt range, that's 128 bits. So the reason why we use a unit 256, like I said earlier, is like for compatibility with Ethereum, right? So if you go through on Ethereum, right, like numbers like, let's say, the total supply and every other thing, it's normally in unit 256, right? So like I said earlier, there was a discussion regarding this, right? There was a discussion regarding whether we should go with all fields or just unit 256 that was during the earlier days. And it was finally agreed, although it's still something that's still that a lot of persons still feel it's not necessary to. It was agreed that if we are going to like be compatible, it's compatible, right, with Ethereum, there's a necessity to use Unit 256 where certain standards in Ethereum uses a Unit 256, which some persons also argue is not necessary since StarkNet decided to go out of the box and to use Cairo. There is no EVM compatible. So what's the need to do all those? But then there's still a need to do that. But we are out of time. It's 6:42, right? Just send me a DM on Telegram and we'll probably talk about it more. So let's just head over and continue what we're doing. So we are going to call, right, so from Open Zeppelin, right? I talked about the Open Zeppelin library. So if you head into the library, this is the library I'm going to be using, right? It has what we call a namespace. So this namespace contains every external function you might need to like it contains every function, exactly every function that you probably need to import and use in your ERC20 implementation, right? So the beautiful things about namespaces is a way to group functions in such a way that if you import in Cairo, if you import the namespace, you automatically import like every single function contained in the namespace. So we're just going to go ahead to import from that's our path should be from Cairo contracts from Cairo contracts dot source dot open zeppelin dot token dot ERC20 dot library. From there, we're going to import the ERC20 namespace. So having imported the ERC20 namespace, like I said, you now have access to the functions contained in the namespace. For example, we have access to the initializer function, which we can actually use to like initialize our function, our ERC, to create our ERC20 token, right? So we're just going to call the initializer function. We're going to call the initializer function. And as you can see here, the initializer function takes in the name, the symbol, and the decimals, right? So you're just going to supply that, the name, the symbol, and the decimals, and we just created an instance of an ERC20 token, right? But we don't want our ERC20 token supply to be 0. So if we stop at here and we deploy this contract, our contract probably have a total supply of 0. So but we want to mint, let's say we're going to call the internal function mint of the open zeppelin library, right? And we want to mint the total supply. Let's be sure first. Head over, if you check out the mint function, right, once you mint to the recipient a certain amount. Now we're going to be minting the recipient probably is any address who you want to have all the tokens on initial deployments, right? So we're going to be minting to the recipient the total supply we want for our token, right? So having done that, we are just going to go ahead and return the return, right? So you must always end your functions with the return keyword. Then let's just open our interface and implement every single function we have in the interface. So we're going to open ERC20.Cairo. Let's open this to the right, open this to the side, sorry. All right, so let's just close this so I have more space. So the first function we want to implement, we're going to be starting from the getter functions, right? So view functions, right? So we're just going to say getters, and the first function we want to start with is the name function. So we're going to I'm still going to be using, the reason why I always use the @external keyword is the VS Code extension I'm using is not detailed. So if you type view and press enter, nothing happens, right? But I don't want us to waste too much time typing all those implicit arguments. So we're just going to use the @external keyword just to get the template of a function, right, containing the implicit arguments and stuff. And we're just going to change this to view. So the name function does not take in any arguments. It doesn't take in any arguments. Let me try to toggle this because I can't find a way to do this. Toggle. Does this work? Shit, not that. So anyone knows I did this from VS Code, but I can't currently toggle using my keyboard because I made the modifications to it earlier, not to be compatible with the keyboard I bought recently. Now I'm trying to like toggle. Keeps giving this, and there's not much time. So let's just move on. So we're going to return a name, right, which is of type fields. This is very inconvenient. Appearance, wardrobe. That should do. Yeah, that's it. All right. So we're going to, for the name, right, we want to just return if we read if you check the library, right, you can see the name function has already been, the name getter function has already been implemented for you. So you are simply just going to return the name, right? So we're just going to say return the name function, right? Okay, let's just make things fairer. Let's just do this. Let's make things just right. We're going to return name ERC20.name, right? And we're also going to come here and return name is equal to name, just to make it syntactically better, and readable. So I'm just going to copy this because I'm just going to copy this and paste it, and I'm just going to change this to symbol, right? So implementing the symbol function now, and this is going to return symbol. And let's just change this to symbol and change this to symbol too. Then we are also going to change this to symbol and also change this to symbol. And we are going to do same for the decimals too. We're going to just change it to decimals, then let decimals be equal to ERC20 decimals. Then decimals is equal to decimals. And this is supposed to be decimals. All right, so we are going to also do the same for total supply. So total supply. So for this, we want to return the total supply, and we're just going to get that into the total supply, read the total supply. So as you can see here, the function itself was created with an underscore. It has the function we are trying to read from is total underscore supply. So we're just going to use that, and then we're going to say let total supply equal to total supply, right? Total supply. Right. So next up we are going to return the balance of our ERC20. So we are just going to say balance of so the balance of now, it takes in an argument, it takes in the account arguments, account type fields, and it returns a balance which should be of type UNT6. So we are going to say let balance be equal to ERC20.balance of, and we're going to query for the particular accounts, those arguments, the account arguments, right? And we're going to say let balance be equal to balance. All right, so having done that, we are going to implement, I think the last view function we have here is the allowance function. So we're just going to implement for that the allowance function. Now this takes in how many arguments? Owner and spender, right? So we are going to pass in the owner and the spender. All right, first of all, I want to believe that every single person here understands the ERC20 contract interface, right? If you don't understand, just head over to the EIP. Let's check EIP ERC20, right? Just head over there and just read up on the ERC20 token standard, right? I don't have so much time to explain it, but going through this, you should be able to like have a proper understanding of the ERC20 token standard here. So yeah, owner spender, and this return the remaining, right? This return the remaining. Yep. So we are going to just say let's remaining be equal to ERC20.allowance, and this should return remaining to be equal to remaining. All right, so next up, we're just going to implement our transfer function. Now these are external functions, so I'm just going to create just create a little demarcation, externals, right? And we're going to start with the first external function, which is transfer. So that's the transfer function, and the transfer function takes in a recipient or fields and an amount of UNT6, right? Right, and as you can see here, we are actually returning a success variable. So that's but just specifies the status of the transaction, was it successful or not. Now to do that, right, we're going to go up and we're going to import the Boolean value true and false from stackware dot I think dot Cairo dot common dot bool. We're just going to import true. So if you head over to the Boolean Cairo.common.bool, right, in the library, true basically is just a representation for 0 and false is a representation for 1. So basically we're just returning the Boolean variable 0 for 1 and 0 and 1, 0 for false, 2 for 1, right? So we are going to say we're going to make a call to transfer function in the in OpenZeppelin's library, right? We're going to make a call to transfer function, passing in the recipient and the amount. And if that is successful, we just simply want to return sources is equal to true. Also, another question you might have is, if you check the repo, I might probably have done true, comma. They're basically the same things. Your return value is normally in its full form. So most times when you specify, either you actually do this right, so says it goes to true, or you put the comma indicating we just needed the first, what is called it, the first stuff in the tuple, right? So you are just going to head over and implement the next external function, which is transfer from. Sorry, in so much hurry because we're out of time already, and I really need us getting to at least the ERC721 contract. So for transfer from function, we are going to, I just stop here and continue tomorrow. I think the main thing is to probably be understanding what we are doing than probably rushing and no one understands anything. So let's just move on. So we are going to be implementing a transfer from function, and as you can see, we accept 3 arguments as a sender, which is of type fields, the recipients, which is also of type fields, recipient of fields, and the amount, which is of type U256, right? So for this, we're just going to call the transfer function, transfer from function, and we're going to pass in our arguments, sender, recipient, and amounts. Right. So having done that, we're just going to simply return sources is equal to true, right? Let's just stick with one format. Then lastly, we are going to be implementing our last function, which is the approve function, right? We're just simply going to say at external, and we're implementing our approve function. It takes in a spender, right? A spender of type fields and an amount of type U256. Okay, this also returns the status of the transaction, that's sources fields. Then this also returns the status of the transaction, which is sources fields, right? So we are going to call the ERC20 let's approve, and we are going to return, okay, that's successful, right? All right, we're going to pass in the spender as the arguments, the spender and the amounts. All right, then we are going to return, that's successful, we just want to return success is equals to true. And I think that should be all for our ERC20 contract. We just implemented all the functions contained in our interface, right? So we're just going to head over to our put.l file, and we are going to uncomment this guy here, and it points to ERC20.Cairo. Okay, so let's try building that file. So let's say protostar view. All right, so if you have any questions, please ask on the chat, because we are going to stop here for the meantime. Okay, there's an error. So it says cannot cast these to fields. All right, I made a mistake. So heading over to ERC20.Cairo, total supply, this is supposed to be U256. That was a mistake. So let's try building again. Oh, well, yeah, allowance. We also made a mistake in allowance. Allowance takes in some arguments, and I didn't pass that. Where's it? Where's it? All right. So allowance takes in an owner and a spender. And let's try building once again. Well, seems like we have a low errors 256. Yeah. I keep making that mistake. So let's head over to allowance. I think that should be in our allowance. Yeah. So this is supposed to be in 256. Let me just check if I made that mistake anywhere else. Okay. Let's try compiling again. Let's clear this guy. It's looking too clunky. Then let's just start build. All right, so we finally built our contract. So we're just going to head. If you head over to the build folder once again, you'll see that we now have our ERC20 ABI and our ERC20.json file. So as always, okay, there's no question. So as always, we're going to head over to declaring our contract, right? So start declare. So there's no need to set our private key again, as we have done that previously. So we're going to head over to the declare command, process or declare /build/ I think ERC20.json. And we're going to be passing in our account address, which I'm just going to get from my wallet. All right, our account address, and we are going to be passing in what else? Our max fee, our network. Let's pass in our network testnet. Then max fee, which is auto. So let's try declaring that. All right, so we have our contract declared, so we can just copy that class hash and check if it has been successfully declared, right? Just head over here and search for the class hash. So as you can see here, the class hash was successfully declared, right? So what we're going to head over to next is deploying the contract. So we are simply going to write protostar deploy, right? Then we're going to pass in our class hash. Next up, we're going to pass in our inputs. Let's see. So first of all, we have our constructor takes in a name, a symbol. Both of them are going to be converted from string to field. So we're just going to come here and we're going to call this stack. Okay, let's just call this StarkNet Africa. StarkNet Africa. We're going to copy this and we are going to paste it. That's our name. Our second argument, our symbol, we're just going to use let's just use surf, and we're going to copy that and we are going to paste. Our third argument is the decimals. Our fourth argument is the total supply. Now the total supply, remember, when it's a struct made up of two fields. So when you are specifying it in your terminal, you need to specify both the low and the high value. So the low value is going to be, let's say we want our token to have a supply of 1,000, right? Our low value is going to be 1,000. Our high value is going to be 0. And lastly, the recipient. I just want the recipient to be my account, the account I'm using to deploy, right? So I'm just going to come here and paste that in. So I'm also going to need to pass in the account address to the deploy command, right? The account address I'm deploying from is this guy. And I'm going to pass in the network, which is testnet. And I'm going to pass in the max fee, which is also. So now let's try to see if our contract gets deployed. All right, so we have our contract deployed at this address. So it probably takes some while. So but while you wait for that to get deployed, let's see, there's a question. Sorry, why is high 0? Okay, so the value 10,000 does not stretch into, does not exceed 128 bits. So basically we are just padding it with zeros. I'll probably send you a link to an article that explains this in details, but the way it works is, so far the value you are declaring, right, fits into the low value. That's the 10,000 fits into the first 128 bits. So we just pad the rest with zeros. That's why we can write 1,000 0, you get, because 1,000 fits into 128 bits. I don't know if that answers your question, but if it doesn't answer out, there's this resource I used to understand fields. I'll probably send that to you too. It helped a lot. Well, okay, so let's check our contracts. Let's see if it was successfully deployed. So we're just going to head over to StackScan and we are going to search for that contract address. Yep, and we can see our contract address was successfully deployed, right? So there's a chat. So okay, it's closed. It's closed. Sorry, what's closed?
Like the answer you gave is close, but it's not like very, very clear.
Okay, we are already 2 minutes behind schedule, right? So just let's talk on Telegram, please. I'm sorry about how the class went today.
All
But
right.
let's just talk
all
on
right.
Telegram. Let's just round this up, right? Yeah, thank you.
All right.
Right. So so the name, so if you query for the name argument, right, you should get returned StarkNet Africa. And if you query for the symbol, right, you should get returned SAF. If you query for the decimals, you should get returned 18. You should get returned 18. And if you query for the total supply, you should get returned 1,000. If you query for the balance of my account, since my account has all the funds, right, if you query for the balance, you should also return 1,000. We should return 1,000, and so no account has an allowance yet, so that's it. So let's say I want to transfer from one account to another. I could just simply connect my wallet, my Agent X wallet, right? And I am going to go to transfer, probably copy the contract address from, okay, let's say account 2. I'm going to copy account 2's contract address, head back to account 1. And okay, let's just disconnect and connect once again. Audience extra. So I'm going to paste in the recipients, that's this guy here, and I'm going to transfer 100 tokens to him, and I'm going to try writing, and I would approve the transaction. Once that is done, we'll go back to the read contract and query for the balance of the accounts I just transferred to the recipient, and we should get 100 tokens. And so we are out of time already, so we'll not be able to touch the ERC721 contracts, but tomorrow is going to be better. Tomorrow is going to be better. I'll probably have to stay away from home tomorrow. So we are going to start from where we stopped. We are going to build the NFT contract. Then we are going to build the ERC721 contract, right? The NFT contract. After which we are going to go ahead to build the marketplace, the NFT marketplace contracts, right? So we are going to go ahead to build the NFT marketplace contract. And if there's time also, we'll build the AM contract. So on Sunday, the whole idea was to use the whole of Sunday for messaging bridge and upgradability. But even if we can't, probably just touch these two, then keep the messaging bridge and upgradability for probably Monday, or probably Monday. Yeah. So but meanwhile, you could just try your hands out, try playing with it, and yeah, I'm definitely sure you'll be able to do something. So let's check our the stuff went right. So we're just going to query for the account, and as you can see, it has 100 tokens. So yeah, that's just about it. So like I said earlier, the goal of the repo is not to have you cram codes, right? So if you know the interface is not enough, just like I did earlier with ENS, just simply list out all the stuff, probably explain the logic. The way I do stuff is try to understand the logic yourself, and your goal as a developer, right, is to be able to use codes to solve problems, use codes to build logics. Yeah, that's about it. Tomorrow we'll look into the NFT contracts, NFT marketplace contracts, the EMM contract. So let's just see how tomorrow goes. And if you have time, definitely come around. Tomorrow is going to be way better. I sincerely want to apologize once again for how today went. And I think we'll just round it up here. Thank you so much, guys. Thank you so much for coming around. Yeah. Yeah, thank you. You're welcome.
Thank you.
Yeah, thanks, man. I mean, and for anyone that has more questions, just ask in the Telegram group. I think it will be even helpful for people that didn't like get to attend the live classes, right? So and tomorrow by the same time we also like have this class as well, and we'll have the last one on Sunday evening, right? I think that's the case, Darlington.
Yeah. The idea is to have the last one on Sunday evening, but if we can't, although I think some contracts are easier to build yourself if you understand the previous. So the idea tomorrow is to make sure we touch on the NFT contracts, the NFT marketplace contracts, and the MM contracts. If you understand the NFT marketplace contracts, you should be able to work on the ICO and the staking contracts. But if we can, we'll definitely touch the staking too, since that is a little more different. But let's see how things go, Sha. But the idea is to round up.
Yeah, cool. Well, thanks guys for joining
Sunday. So
okay.
Right. Take care, everyone. Yeah.
Yeah, take care.